All right, welcome back. Let's do this integral. Let's say that I want to integrate x over the square root of x plus 1 dx. This one's a little more tricky than the last two. Turns out that this is an integrand that involves a composite function, but I could recognize that composition in a couple different ways. And sometimes there's actually more than one way to substitute that will work for you. So I'm going to do this one a couple different ways just to show you how that might work. So let's see. Way number one. I'll look at my integrand and figure out, well, is there a composition in there? Well, it looks like this denominator is a composition of functions. So what if I called this part g of x? Let's maybe let that part be g of x, which means I am calling u equal to x plus 1. That's my first method. Okay. Now let's see. Let's find du. Du is equal to, well, du dx is equal to 1, which means that du is just equal to dx. So let's do some substitution here. The integral of x over the square root of x plus 1 dx is equal to the integral of x over, I called that denominator underneath the square root, I called u, and then dx, I called du. Okay. Now, let's see. It looks like I still have an x in this integrand. How could I take care of that? Well, let's look back up at step 1. And you might note that since u is equal to x plus 1, if I subtract 1 from both sides, that means that u minus 1 is equal to x. So maybe I could substitute that for x down below. Let's do that. This is equal to the integral of u minus 1 over the square root of u du. Okay. So I'll make a little room up top. I'm wanting to find the integral of u minus 1 over the square root of u du. So now I have the nice feature that there are no more x's left in my integrand. And so now I have to think about, well, can I integrate? Do I have a rule that allows me to find the antiderivative of this portion? I don't, but it looks like I could do a little bit of algebraic manipulation and rewrite that in a form that I do have a rule for. So this becomes integral of u divided by the square root of u, or divided by u to the 1/2, minus 1 over u to the 1/2 du, which is equal to the integral of u to the 1 minus 1/2, which is 1/2, minus, I'll switch the sign on the exponent there, minus u to the negative 1/2 du. That one I know how to integrate. That one I can apply my rules of anti-differentiation and find the indefinite integral. So let's do that. Let's find the antiderivative. 1 over 1/2 plus 1 is 3/2 times u to the 1/2 plus 1 is 3/2 minus 1 over negative 1/2 plus 1 is 1/2 times u to the negative 1/2 plus 1 is 1/2 plus c. Okay, so let's rewrite that so it looks a little cleaner. That is equal to 2/3 u to the 3/2 minus 2 u to the 1/2 plus c. So I have an integral. Now that I have that integral, I can rewrite it in terms of x. I've applied my rules of anti-differentiation, so I no longer need that variable u. I can bring back in the fact that I called u, what did I call it? I called it x plus 1. So I can resubstitute here, and I get 2/3 times x plus 1 to the 3/2 power minus 2 times x plus 1 to the 1/2 power plus c, which you can write it like that. Your homework, if you watch it solve things for you, might write it like this. It might write it as 2 times the square root of x plus 1 cubed, perhaps, divided by 3 minus 2 times the square root of x plus 1 plus c. Something along those lines. Okay? But either way, those answers are equivalent. All right. Let's do this a second way. There is another way that I can recognize this function as a composition. This is way number 2. And I'm again integrating x over the square root of x plus 1 dx. If I think about this as one function over another function, that could be a composite function. So maybe I could call this part u, or g of x, which I'm calling u. So I'm going to let u equal that g of x term, square root of x plus 1. I can use that to find du. Du dx is equal to x square root of x plus 1. I can write as x plus 1 to the 1/2, as you know. So the derivative is 1/2 times x plus 1 to the 1/2 minus 1, which is negative 1/2 power, times the derivative of x plus 1, which is 1. So that is equal to 1 over 2 times the square root of x plus 1. All right. So du dx is equal to 1 over 2 times the square root of x plus 1. Maybe I'll multiply dx by both sides, and I get that du is equal to dx over 2 times the square root of x plus 1. So I've got that. Now I'm going to try to substitute. Let's look up above. And let's see. I can rewrite this integrand as follows. This is equal to the integral of x times 1 over the square root of x plus 1. dx, which is, or I could actually even write the dx term up here if I want to. Write that dx term here. That term is almost like this term, with the exception of the 2. Let's see here. Could I potentially multiply both sides of that bottom equation by 2? Let's multiply this side by 2, multiply this side by 2, and then I get that 2 du is equal to dx over the square root of x plus 1. So I can substitute. That term on top becomes the integral of x times 2 du. All right. Okay, now let's look at our integrand. Integral of x times 2 du. And I know what you might be thinking, well, I didn't actually use u. Sometimes that'll be the case. I'll recognize that my derivative, which is kind of a complicated portion of that integrand, is actually my du term. So I can rewrite it as that portion, and that'll kind of simplify my substitution process a little bit. So in this one, I have not yet substituted for u, but now I'm going to use the fact that I know what u is to say, well, I can't have an x in my integrand. I have to rewrite everything in terms of u. So let's use what I've called u to rewrite that expression in terms of u. Okay. So you might recall that u I called the square root of x plus 1. Maybe let's solve for x. So I'm going to square both sides of the equation to get rid of that square root. That gives me u squared is equal to x plus 1. I'm going to subtract 1 from both sides, and I get that u squared minus 1, is equal to x. So I can take this and I can substitute it for x in this equation. That is equal to the integral of u squared minus 1 times 2 du, which is equal to 2 times the integral of u squared minus 1 du, because I can move that constant out front. Okay, now after all that work, can I integrate? Well, it looks like this function is in the form that I have a rule for. I know how to find the antiderivative of that. So that becomes, actually I'm going to do it over here, that becomes 2 times antiderivative of u squared minus 1, which is u to the third power, u to the third power times 1 over 3 minus integral of 1, which is u, all of that plus c. So I have that integral complete. Now that I've applied my rules of anti-differentiation, I no longer need the u. The point of that u was to allow me to rearrange the function in such a way that I know how to integrate. Now that I've done that, I can resubstitute using what I called u. This is equal to 2 times 1/3 times u, which is square root of x plus 1 cubed minus square root of x plus 1, all of that plus c, which if you rearrange it using algebra a little bit, you actually get that exact same integral as we got when we used the other substitution. Okay, so we will stop there for today. and I will talk to you guys tomorrow.